Hey everybody and welcome back. Now I did some cursory scanning of all of the videos that cover how to deploy Traefik, and all of those videos that I found, including my own, have this same problem. It's a security issue. I want you to pause the video now and have a think what that might be. I'll give you a clue. It's the way that we route multiple different containers through the same instance of Traefik. Okay, did you work it out? Well, the issue is we're hosting both internally designed applications, i.e. things that are designed to manage your infrastructure, PiHole, Portainer, Vaultwarden, etc., and things that are designed to be externally hosted, so things like Plex or Jellyfin or a web server. The issue is if you don't have some careful configuration, all of those web GUIs are going to be available to the internet. And that obviously increases the attack surface, and these applications will typically be holding sensitive information or allow you to control infrastructure, which is a big no-no. So how do we fix that? Well, I'm going to give you three options in this video, ranging from security through obscurity, that usually just buys you time, i.e. is the weakest control, and then two other options which are a bit more involved, but still there's nothing mind-blowing here. So let me just demonstrate what the problem is first, and then we'll slip into solution mode. So if I head over to my virtual machine, and here you can see that I'm connected through a VPN, that means that I'm not using my local network, so those firewall rules are going to be bypassed. Now if I head into my hosts file, and this doesn't have to be your host file, this could be your DNS resolver, so something like PiHole, and if I put in a custom record that says my external IP and the service I want to access. So for this instance, I use Vaultwarden in my home lab and it's restricted internally. But if I use the default Traefik setup that is in most videos, that's going to be accessible to the internet. So the only real barrier you have to accessing somebody else's Vaultwarden in that situation is just to know their external IP address. Now, even if they don't have a CNAME record at their domain registrar, you can just create your own record in your own DNS resolver and you will be able to get to their site. So you kind of see what the problem is here. You could have a person running a Vaultwarden or a PiHole. They haven't created a CNAME record and they think that that's not externally accessible. But as long as they have a root domain, which points to their actual IP, which is why I always say it's a good idea to hide your IP, you can manually create a record and access that service. So now we've discussed what the problem is with the default setup. What can we do? So I'll take you through those three options. The first option is to use something like Cloudflare. Now, don't worry if you're not using Cloudflare. I'll come on to the other two options in a moment which don't require the use of Cloudflare. But I recommend you do this anyway, regardless of whether you choose option 2 or option 3. So option 1 is to make use of Cloudflare proxies. Now what a Cloudflare proxy does is expose its infrastructure instead of yours. So this sits between your service and the client that's trying to access it, such that when they resolve your DNS name, it points to Cloudflare's infrastructure and not your own. Now that resolves the issue that I just showed you with manipulating the host file or creating a custom DNS record. Because instead of jimsgarage.co.uk pointing to my IP address, it points to Cloudflare's proxies. Now that's great because if we then create the custom DNS record and try and point it to a Cloudflare tunnel, it won't work because that service, i.e. vaultwarden.jimsgarage.co.uk, isn't specified on that IP address. So although this is technically security through obscurity, which at the best buys you some time, it does mean that by hiding your IP address, you're creating an additional barrier to overcome the issue we just spoke about. So I recommend for all of your services, if you're using Cloudflare, turn on the proxy wherever possible to hide your public IP address. Unfortunately, that's not possible for some protocols. So things like WireGuard, for example, you can't route that through Cloudflare's proxy. So what you could do in that instance, and again, it's more security through obscurity, is create a random subdomain so that no one could guess it. because there's no easy way to dig through all subdomains that relate to a top-level domain. So having covered the Cloudflare proxy trick, let's get on to some of the more robust technical changes that we can make to introduce some more security and segmentation between our internal and external apps. So this second option, as you can see on screen, involves changing some configurations within Traefik. Now, if you've been following my guide, you probably have something that looks like the one on the left. Here we have Traefik set up running on port 80 for HTTP traffic and 443 for HTTPS encrypted traffic. And we've set up a redirect to redirect 80 to 443. We've set up some labels and we've even put in some middlewares like Authelia. And this is great. It works, we've got valid certificates, but it introduces the problem that we're here to solve. So the way to fix this is actually over here in the port section and over here in the Entrypoints section. Can you think what that might be? Well, what we're going to do is to create new entry points. Now we're going to have 2 entry points that are designed specifically for external access, i.e. from the internet through the firewall to our proxy, and 2 other entry points which will just be for internal. Now in this instance, I recommend leaving port 80 and port 443 for your internal services. That might sound counterintuitive, but actually it can make things a lot easier, especially if you're accessing services on the same subdomain that wouldn't be routed through a firewall, so we can't do fancy things like NATing. That will mean that when you put in HTTPS or plain HTTP, you won't need to do anything fancy with altering the ports. It will just work. Now, if we create additional entry points external that we know are going to be routed through a firewall, as I've shown in previous videos and I'll show again later, we can put in destination NAT rules, which means that we could host our services on any port and it could be routed internally. Or we could stick it still externally. We could open up port 80 and port 443. But actually, we route those internally to, I don't know, port 81 and port 444. That means it's the same user experience for the user. They simply put in HTTPS or just put in your URL and let the browser do the rest. And it will behave exactly the same because our firewall is sending it to the Traefik proxy port it expects. So let me go ahead now and I'll tweak these files and I'll walk you through what these changes are going to do. So here I've tweaked the configs. I've added 2 new ports in the Docker Compose file, and remember we're going to have to redeploy this for those changes to take place. And on the right hand side within the traefik.yaml, the configuration file, I've added 2 new entry points. So I've added HTTP external and HTTPS external. Those are different from the HTTP and the HTTPS, which I'm going to use purely for internal. So let me redeploy that and I'll log into the dashboard and we'll take a look. So now back in Traefik, you can see that these entry points have been reflected. We've got external on 81 and external on 444. So now we're in a position that we can begin to use these. And to do that, it's pretty simple. We just need to go back into the Docker Compose file for the respective external application. Remember, we left 80 and 443 as is, and we're going to use those for internal applications. And now anything we want externally exposed, instead of attaching it to HTTP and HTTPS, we attach it to HTTP external and HTTPS external. You get the idea. So let's go and do that now and we can demonstrate this in action. So in this instance, I'm going to use Jellyfin because this is something that most people will probably want to have externally available. So if you look closely in the Docker Compose file, I've changed here the entry point to be HTTP external and that redirect to be HTTPS external. And remember, those are the new entry points we've created and we validated that they were up and running within the Traefik dashboard. So now we're in a good spot to get this up and running. And the final change that we need to make is going to be within the firewall. So currently we have port 80 and port 443 exposed to the internet with a port forward. But now we're going to tweak that. We're still going to leave port 80 and 443 open, but instead the destination that it's routed to isn't going to be port 80 and port 443 on our Docker host, which, remember, is where Traefik is listening. Instead, it's going to be port 81 and port 444. So that means that only the services we put on those entry points are going to be accessible to the internet. So the trick I showed you with the host file manipulation or adding your own custom DNS record within PiHole isn't going to work, because those services, things like Vaultwarden, PiHole, Portainer, they're not on that entry point. So effectively, we've created a bit of a network black hole. So when it port forwards traffic from port 80 and 443 on our firewall, it's going to get routed to that entry point, and there's no DNS entry on that entry point. So Traefik's going to say there's nothing here, and it's going to give an error. So over on my firewall, I haven't made any changes yet, and you probably have something similar. You have a destination NAT rule, a port forward, which says any source, so anyone on the internet, coming in via your WAN, can access using these services, and if we look here, this is port 80 and port 443, which is what we used to be using. Remember, we've changed the entry points now. And they can access the Traefik instance, which in my case is my Kubernetes Traefik host. And crucially, we have the translated service here, the PAT. And this is currently at original. And this is what we're going to need to change. So instead of these original services being port 80 and port 443, we're going to need to create some new firewall rules, which takes port 80 and port 443 and translates them to the Traefik proxy on 81 and 444 respectively. So I'll show you what one of those rules looks like now, and you can just replicate that in your firewall. As I keep repeating, I'm using Sophos, but the same principle applies. You just need to do a port forward and a port translation in your firewall. So now that's updated, and you can see the difference. I still want Traefik to come on 443 because that's pretty much what the world will be expecting my service to be listening on. If you're not going to use 443, you'd have to specify the port at the end, which can be a bit frustrating, and some apps just won't work with that because they don't allow you to specify the port. But the key thing to fix that is here. I've changed the translation to be port 444. So 443 will hit my firewall from the internet, and then it will get routed to port 444 on my Traefik instance. And now, because of the Docker Compose file, Traefik is listening on port 444. We have an entry point set to port 444, and we have services like Jellyfin which are using port 444. I don't know how many times I'm going to say that this video, but hopefully you get the idea. So back on my VM, and now with that firewall change in place, let's try and access the Vaultwarden container that I've got on my Docker instance. Now remember, that's listening on the internal, so just the HTTP and HTTPS Traefik entry points. And as you can see here, we get a 404 not found. So great, that means that people on the internet now can't use that old method, and they can't access my Vaultwarden. That's because it's being routed internally to an entry point that service just isn't listening to. So it's falling into that black hole. Conversely, because we've got Jellyfin now running on that HTTPS external, it's still accessible because it's taking Traefik on my firewall from port 443 and it's changing that to port 444 where Jellyfin is listening. So great, that concludes option 2, where we've created additional entry points and put internal services on an internal only entry point and external services on an external only entry point. And if you're wondering how's my internal traffic, i.e. users internally, going to access my Jellyfin, is it going to have to go over the internet? No, there's a concept called hairpin NAT. Have a look at what that is for your firewall and make sure you enable it. In Sophos, it's created when you go through the firewall wizard, and it means that instead of having to route out to the internet, it's kind of like a hairpin, it bends back on itself. So it knows that you're hosting that internally, and it will send that traffic directly to the proxy without ever leaving your network. So with option 2 out of the way, it leads nicely into option 3. And that's to make use of Traefik IP whitelists. Now, if you've been following my video so far, you could have option 1, do option 2, and even do option 3, which would be a good basis for this. So an IP whitelist is basically a firewall. It says where the source of traffic can come from for that particular container. So let's have a look at that. So in the example on the Traefik website, we can see that we're going to add a middleware to a container. So this would be specified within the Docker Compose file. And we can see that for this application, traffic is only allowed from the source range, i.e. the person connecting or computer connecting to this service. It can only be from the local host, i.e. the machine it's on, or this IP address here. And you can change those to be CIDR rules, so /16, /24, whatever, to make sure that all devices on a given subnet can access it. So let's go and add this rule now to our Traefik, and let's see what happens. So just to demonstrate, this is the Vaultwarden instance that I'm reaching on my local machine. This is the machine I'm recording this video on right now. And this machine has pretty much open access to all of my network. So I can access Vaultwarden on it. So let me go and add the IP whitelist now to restrict access, and we'll see what happens. So to do that, we're going to jump back into the Docker Compose file and make some tweaks. Now I did just mention the Docker Compose file, and you could go and do that on the respective container. But instead, I'm going to follow the same approach that we did for when we installed the CrowdSec bouncer. So to implement the IP whitelist, we're going to need to open 2 configuration files for Traefik. Those are the traefik.yaml file here on the right and the config.yaml file here on the left. So on the left, we're going to create a new HTTP middleware, which is what was specified on the Traefik website. So here, underneath the CrowdSec bouncer, I've added IP whitelist. Don't worry if you don't have the CrowdSec bouncer, you don't need that for this to work. It's another middleware, and I've got a video on that, and I recommend you go and get it, just so that you're scanning all of the traffic that hits your proxy. So add the IP whitelist section here, and tweak this IP address here to something that you want to give access to. So it could either be a static IP, like it is here, or it could be a network range for all devices on a given subnet. I've deliberately chosen something here that won't work because I want to show you what happens when something is outside of that whitelist, because the whole point of this video is trying to restrict access to certain containers based on rules and configuration settings. Now on the right hand side, we're going to specify where this IP whitelist is applied. So we do that at the entry point level. So within the HTTP entry point, under the middlewares, I've specified the IP whitelist at file. Now, because we're using a redirect scheme, which you can see down here in the bottom left on the actual Docker Compose container file, we need to also add this IP whitelist here under the HTTPS middleware. So when you've added these two to the respective entry points, and you've added it to the config, you want to go and redeploy Traefik. And once you've redeployed Traefik and you've checked that everything's working, when we now go back to the web page here for Vaultwarden and do a refresh, fingers crossed, we should get a forbidden message. And we do. Great. That's because my machine isn't 1.2.3.4, and therefore it's banned because it sits outside of the whitelist. So now, a bit like a firewall, you're able to granularly control exactly which IPs or networks you want to access on a given entry point. And that's a pretty powerful tool. So that wraps up option 3. And I do have actually a bit of a bonus, but it's more of the same, if that makes sense. So the fourth option would just be to deploy 2 Traefik instances in parallel. So you could have one Traefik instance specifically for internal traffic and one Traefik instance specifically for external traffic. Now those containers would probably look similar to what we've got in the blended approach. You would probably have your internal traffic assigned to 80 and 443. And again, you would have that external traffic instance assigned to something like 81 and 444. It doesn't really matter as long as you're consistent. And from a true security perspective, that would probably be the most robust solution, because you've got logically different architecture that is segmented at the application level. But that creates a lot more administrative overhead, and you need to decide whether you want that or whether you would be happy with something like I showed, where we can split one instance to isolate internal and external traffic. And we can go further by using IP whitelists on given entry points for given containers. So thanks for watching, everybody. I hope that's now given you some of the tools, or at least options, that you can employ on your traffic instance to get back some of that control. So now you can granularly restrict which services, which IPs can be accessed, and you also have segmentation between your internal and external networks. Let me know in the comments below which option you're going to choose and why, and thanks for watching. Please like, comment and subscribe, and I'll see you on the next video. Bye bye.